differentiate with respect to y, which is going to be 4. Similar manner, if I want to differentiate y, I can differentiate in 2 ways. Getting partial 2z, okay, partial y squared, which is going to be a 2, or getting partial 2z, partial y, partial x, which means I will differentiate this function with respect to x, which is going to be 4. That's the second derivatives of a certain function. Bottom line, the first derivative, I'm dealing with the function, with the rows and everything. The second derivative, I will treat the first derivative, okay, as the main function, and I will continue with the derivative. So, once more. Once more, this is partial 2f partial x squared, which is going to be the second derivative of f, partial 2f partial y partial x. So the first derivative with respect to x, the second with respect to y, partial 2f partial x partial y, the first derivative with respect to y, then the second with respect to x, partial 2f partial y squared, the first derivative with respect to y, the second will be with respect to y, that's the second derivative. I can increase the derivatives for higher order as much as you want, okay? Okay, طبعا that's the generalization that I'm telling you about. I can find a higher order. For this problem, I'm not going to lose time in solving this problem, but it is really a very important one. It's one of the one-dimensional wave equations in 2 dimensions, where you have u, which is the second derivative of u for 2 times, and it's going to equal to the partial derivative in the direction of x. This is why the partial derivatives is really very important, because it is measuring, it has plenty of engineering applications, and it has a physical meaning and interpretation for plenty of the physical problems around us. Like this guy explaining the temperature movement through a rod of certain material, okay? This equation with the partial given equation displays this value. That's the wave equation. Sorry, that's the wave equation, not the heat. The heat is going to be first order, but for the second order, it's the wave equation which translates the wave or vibrating string or something like this. Those are the explanation. U, it is the displacement. C, it is the speed. Partial U, it is the acceleration. Partial U is with respect to partial H, the curvature of the string through a certain medium. It's one of the applications, as I told you. Here, for example, he wants you to show us that u sine x minus ct is a solution of this equation. Any idea how to prove this? How to show this? I want to show that this is the value of u, which is sine x minus ct. It could be a probable solution for this problem. How to do it? It's very, very simple. I will differentiate this function 2 times with respect to t. That's the left-hand side. And then I will take the right-hand side. I will differentiate this function 2 times ya Farid, but with respect to x. After differentiating, I will multiply it in c squared. You will find the left-hand side is equal to the right-hand side, so it's proved. شباب انتوا معايا؟ ازاي اقدر اثبت دي؟ It's by the idea. This problem is going to be much difficult and with plenty of methods. I believe you will take this in math analysis 3. How to solve the partial differential equations. In this problem, it is already solved.
هو الماث بيقف امتى؟
يعني احنا
لسه السنة الجاية. You will have mathematical analysis 3.
وبخلص. يعني هو السمستر اللي جاي ماثماتيكال اناليسيس 3 وخلاص كده ماث خلص. والسمستر 2
لا فيرست بس. الماثماتيكال اناليسيس 3 at the time being شباب في الوقت الراهن انت بتاخد ديريفاتيف this course will finalize all methods of integration by the end of this course. So integrating antiderivative in functions and several variables also in plenty of ways. By the beginning of your next mathematical course, you will take solutions of functions like this, of problems like this. That's a partial differential equation. But in this problem, you don't have to solve the problem. I already have the problem and the solution. I want you to show me that this value could be a check for this problem. How to do it? It's a training on partial derivatives. Okay, instead of losing time, Tala, let me try it with you. Faisal, can you get the left hand side? Left hand side. Differentiate how many times? 2 times. Mean this function with respect to t. Differentiate. Differentiating sign. The first time it's gonna be cosine. Am I right? Cosine x minus ct times mean ya Farid. And I've differentiated with respect to t. Differentiating sign is gonna be cosine x minus ct times derivative t1 times negative c. So the value is negative c times cosine x minus ct. Can I differentiate once more? Can I do a second more derivative? Yes, I can. If I want to differentiate once more, then differentiating cosine is going to be a negative of a sine. So simply, it's going to be negative c times negative of a sine of an x minus ct times another c. So actually, the left-hand side, معايا Mr. Faisal? The left-hand side is going to be c squared times sine of x minus ct. Let's look to the right-hand side. كده خلاص, the left-hand side. Okay, right-hand side. Ziad, the right-hand side. This is sine x minus ct. Let's get the first derivative, but with respect to x. The first derivative with respect to x is gonna be cosine of an x minus ct. Am I right?
Yes.
Differentiate once more. It's gonna be negative sine x minus ct. صح؟ بس الليفت هاند سايد في الديريفاتيف واضربه في كام؟ لا في c square. طيب this value times c square. You will find this value is equal to that value. Am I right? ما هو ده نيجاتيف طبعا just a second عشان في ساين. ده لما بضرب تاني ده الفيرست ديريفاتيف. Okay, I'm sorry. This is the sign. So they will be equal to each other. Why the sign is negative? This is negative c cosine x minus ct. Once you differentiate once more, the cosine will be negative of a sine, and also t will give you negative c. So they will cancel each other. So still the value will be negative. This is how to prove. It's really very simple. Okay? It's a direct application on how to make the derivative, as you can see. So once more, this is the partial derivatives. Okay, there is also another very important application in the multivariable function, which is the gradient vector. بص فاتن, the gradient vector actually gives the normal vector on a surface at any point, and at the time being you can evaluate it just like that. How to get the gradient vector? Simply differentiate the function with respect to its variables. This is the gradient vector. Bottom line, for example, let me give you this example. That's the definition of the gradient vector. Differentiate the function with respect to its variables. So for example, if I have this function, which contains x, y, ln 1 over z, I want to get the gradient vector. How to do it? It's really very simple. All I have to do, how many variables do you have? 3. Differentiate for 3 variables. The first derivative will be with x. The second derivative with respect to y. The third derivative will be with respect to z. Okay? Let's do them together, step by step. So, I need to get partial f partial x, which is going to be, differentiate with respect to x. It's going to be y times ln 1 over z. Okay, get the derivative with respect to y. Differentiate with respect to y. It's going to be x times ln 1 over z. Okay, I want to get partial partial z. This is f and that's f. I want to differentiate with respect to z. Before we go through the derivative with respect to z, please, so I adjust this value. Instead of dealing with this value in this form, let's consider it x, y, ln z to the power of -1. Is it possible? Yes, of course. Because instead of having 1 over z, I can treat z to the power of -1. And from the properties of the logarithmic function ya fatim, -1d can be put outside. So it's a negative xy times ln z. Differentiate with respect to z. It's gonna be negative xy over z. So that's the 3 derivatives. بص يا فريد كل اللي انا هعمله. Once he asks you for a gradient vector, I will put them beside each other. So that's the gradient vector. Partial f partial x, this value. Partial f partial y, that value. Partial f partial z, that third value. I'll put them beside each other. You can write them this manner, or you can write them with these brackets using commas between them. So either the 3 coordinates or a matrix form, as you can see. Now I will make the substitution. Here is the substitution. That's the value of the first component, second component, third component. I need the gradient vector at triple 1. So substitute. This is going to be 1, 1, 1 and 1. 1 and 1 divided by 1. So the result is going to be 0, 0, -1. I believe one of the problems that I sent to you was about finding the gradient vector at a certain point, which is very, very simple. All I have to do is to get the derivatives and then make the substitution. ماشي? The gradient vector plays a main role in finding a tangent plane to a certain curve. So it's really very important, as you can see. For this function, he's asking you to consider the function f of xy, which is equal to e to the power of 2x minus y. He wants you to calculate the gradient vector and determine the second order partial derivatives of this function. What is the second order partial derivatives of this function? So it's going to be partial 2f partial x squared, partial 2f partial y squared, partial 2f partial x partial y, or partial 2f partial y partial x. How many of them? 4 of them. Differentiating first with respect to x, then second with respect to y, then differentiating every first derivative 2 times. One with respect to him and the other with respect to the other value. So once more, if I want to get the gradient vector, I will differentiate with respect to x and then differentiate with respect to y. So once more, differentiating with respect to x, it will be e to the power of 2x minus y times 2. That's the derivative. Differentiating with respect to y, it will be e to the power of 2x minus y times -1. That's the value. The second step, so the gradient vector is in front of you. I want to get the second order derivative. Those are the first. So this guy will be differentiated once more with respect to to x, I'm sorry. So it's going to be 4 times x to the power of 2x minus y. If I want to differentiate with respect to y, it's going to be minus 2e to the power of 2x minus 1. So once more, that's f double x, which means I will differentiate 2 times with respect to x, same value as I told you. That's f double y, differentiating the first derivative with respect to y once more with respect to y. That's partial f xy, differentiating the first derivative with respect to x, or the second with respect to y. And this is getting the first derivative with respect to y, then differentiating with respect to x. By the idea, I can put them in what's called a Hessian matrix, but this is going to play a very important role down the road. Okay? This is the Hessian matrix. I've thought to introduce it here. It has plenty of applications. بص يا فريد, الهيسيان matrix دي matrix I will use it down the road in order to determine the optimality, if it is a maximum, minimum, or so on. But in case of functions and several variables, those is really very simple. The second derivatives, I will put f double x on the principal diagonal, f double y on the second position of the principal diagonal, then f of xy, f of y of x. This is the Hessian matrix. معايا Mr. Faisal? So it's a direct substitution by these values. Now I have the Hessian matrix. We want you to evaluate the gradient vector. بص بقى, in this problem, which is a function defined on more than one domain, ما اقدرش اعمل derivatives على طول. I will have to use the law. ليه لازم استخدم اللو؟ لأن دي function defined on more than one domain. So once more, I will use the definition of the derivative with respect to x, with respect to y, that's the first derivative, okay? With respect to x, I simplify it as much as possible, because if I want to get the derivative of the second part of the second derivative, this is partial f, partial y, also simplified as much as possible. And in this case, the gradient vector will be these two guys both together, and that's the gradient vector. That's the derivative with respect to x, and that's the derivative with respect to y. There is another part, I'm sorry, but I will have to say this. There is another part which is the directional derivative. I knew that for any function in multivariable functions, I can differentiate with respect to x or differentiate with respect to y. Also, I can differentiate in any vector direction. The steps are really very simple, especially that you know them at the time being. Just to order them together. I will go through a problem directly, and I will repeat talking about this after the exam, okay? But just to keep it short as possible, I will go through a problem. Okay, stop. Let's stop to this problem. I have a function which is x squared y squared. I want to find, خلي بالك مش فاتن, ده واحدة من الأسئلة اللي ممكن تجيب في امتحان. بيقول find the directional derivative at certain point, which is 1 and 1, in the direction of the vector 1 and 2. أعمل إيه يا فيصل؟ It's really very simple problem. So, Miss Solai, I want to find, once more, I want to find the directional derivative, okay, at point 1 and 1, but in the direction of the vector 1 and 2. What to do? I'm going to use this relation. As you can see, I will need to grab the gradient vector for this function. Then I will make dot product, the one that we talked previously in linear algebra, in U, which is the vector that he introduced. But this vector has to be unit vector. Ziad, do you remember how to make a vector to be unit vector? I will divide on the magnitude. So the steps are going to be exactly like this. Fatin, give me the gradient vector for f. How many variables exist in f? How many variables?
2.
Differentiate with respect to x. So it's gonna be? 2. Differentiate with respect to y. It's gonna be?
1.
So this guy is okay. Huh? At 1 and 1. Can you get the gradient vector at 1 and 1? All I have to do is to substitute. So the gradient vector of f at 1 and 1 is gonna be 2 and 2. Is this difficult? Second step. I want you to get the u vector. This is the v vector. I want to get the u vector. So u is gonna equal to 1 and the 2 divided by the square root of the squares of these values. 1 to the power of 2 plus 2 to the power of 2, which means u will equal to 1 over root 5 and 2 over root 5. This is the value of u. All I have to do is to multiply them together. So, in order to get du of f, of the directed derivative in the direction of u, I will have to multiply those two guys. 2 and 2, dot 1 over root 5 with 2 over root 5. Multiply them together. So it's gonna be 2 plus 4 over root 5, which is gonna come up to 6 over root 5. If it was a multiple choice problem, just you are going to choose the right answer. It's really very simple. So it is simple steps, but it has a huge meaning. That I'm getting the rate of change of the function in the direction of one of the vectors. That's good. That's the directional derivative as you can see. So once more, it's really very important. I will show it to you just in a sec. That's the normalization of the vector, which is going to be 1 over root 5, 2 over root 5. How to normalize it? I will divide on the square root of the squares of the sum of the squares of the coordinates. Okay. How to get the gradient vector? The gradient vector, get the derivative of the function with respect to its variables, then substitute. These are the two values. Multiply them together. Now you have your directional vector or directional value. Here he is explaining that I can find the directional derivative, but it's better to get the normalized directional derivative, making the vector as a unit vector. Okay, that's another problem. He wants you to calculate the directional derivative of f along the vector 1 and 2 at the points 3 and 0. So I will use the points 3 and 0, but I will use the vector which is 1 and 2. Similar steps. Okay, the first step, I will have to grab my gradient vector, which means I will differentiate this function with respect to x, then I will differentiate with respect to y. I will use the substitution with the point 3 and 0. Now I'm done. This is the gradient vector. Similar manner, I will make a substitution I will put the vector on a normalized form. So I will divide 1 and 2 on the sum of squares of their coordinates, which is 1 over root 5, 2 over root 5. Then multiplying them all together, you will have 8 over root 5 as the value of your directional vector. Okay. خلاص, it's done. كل same problem. Once more problem, exactly the same for the normalization. There is what's called a Jacobian matrix, and this is the last thing that I'm going to give you today. Okay, also it's a waste not to understand what's the Jacobian and what the difference between it and the gradient vector. Ziad, by the beginning of our discussion, I've told you many times, how many functions do I have? Or do we have? We have 3 types of functions in general بالسؤال. Single valued function يا فاتن, which is a function in one variable, like y equals sin x, like y equal x squared, like y equal whatever, okay? X plus 2 or whatever. We have functions in several variables يا فريد, like z equal x squared plus y squared, or z equal to x squared plus y squared plus t squared plus l squared, okay? Those are functions in several variables. Ziad, we have also vector valued functions. What's the vector valued functions? The input is more than one variable, and the output is more than one variable. So once more, Farid, boss, I have from R to R single valued function. From Rn to R functions in several variables. Ya Farid, from Rn into Rn, ده اللي انا بقول عليه vector valued functions. ده link between linear algebra and through the limits by the ideal. من أحد الأسئلة, one of the questions that you asked me plenty of times, why we are studying all of this? Why we are taking all of this in linear algebra? It's impossible to understand what we are talking about at the time being if you don't have an idea or a clue about linear algebra. بص فريد, we taught this in linear transformations, if you remember, from R into R, from R squared into R, or from Rn into R, from Rn into Rn, which means the input is more than one variable, and the output is more than one variable. Okay? So in this case, I will see functions where the output is more than one function. To keep things also short, I will skip the first part. I will go through a problem which make things a little bit easier. For example, just a second. خلاص خليني بس الاوردر هنا مختلف شويه. خليني ابص على فاتن 5 دقايق وخلاص, بس ما تلعبش موبايل. بص, I have a function from R2 into from R2 into
R3.
لذلك بصي على R2, how many variables? 2. بصي على output, how many functions? That's the first function. That's the second function. That's the third function. How many functions? 3 functions. لما اجي اجيب الفيرست derivative يا فيصل. Once we try to get the first derivative is going to be really complicated because the output is not just only one function. How many functions?
3.
3 of them. So in order to get the first derivative, it's going to be a Jacobian. They call it the Jacobian. And the Jacobian in this case, the Jacobian J of f, it's going to be 3 rows in 2 columns. How to form the 3 rows, ya Farid? I will take the first function, which is 2x. And I will differentiate it with respect to the principal variables. So I will differentiate 2x, بص, partial f1, partial x, partial f1, partial y. I will do the same, but with the second function, partial f2, partial x, partial f2, partial y. I will do the same with the third function, partial f3, partial x, partial f3, partial y. Let's apply it. تعالى نعمل لها application. Differentiate 2x with respect to x, 2. Differentiate 2x with respect to y, 0. Do it once more. Differentiate with respect to 2x, it's gonna be 3. Differentiate with respect to y, it's gonna be 10y. Differentiate with respect to x, it's gonna be 4 of x. Differentiate with respect to y, it's gonna be 3. Now I have the first derivative. Okay? So once more, the Jacobian, لاحظ انه مفيش معلومه جديده. انت بتعرف تعمل partial derivatives، اديتك بس تنظيمه، صح فريق؟ Okay? So once more, okay, I want to find the Jacobian for these functions. أول step, the first step is to understand how the function is working. For the first function, Farid, it's from R2 into R. واخد بالك؟ From R2 2 صح? To one output. So it's from R2 into R. If I want to get to the Jacobian, the dimension will be, this is the number of rows and that's the number of columns. So for this function, I will have a matrix. 1 row, 2 columns, which is a gradient vector. I will differentiate the output with respect to x, then with respect to y. That's the dimension. That's the gradient vector. طيب يا زياد, for this function, it represents from R into R2. It's a vector valued function. From R into R2, vector valued function. If I want to differentiate or to find the Jacobian, the dimension will be 2 times 1. So it's a 2 rows, 1 column. لاحظ فريد, ال 2 rows اللي انا هبدا اشتغلهم من هنا هيبقى الفيرست رو, خدت بالك ده مش بارشل, ده توتال. تعرفي ليه توتال يا فريد؟ يا فاتن؟
عشان هو من
لانه هو فاريبل واحد. ما انا بستخدم البارشل لو كانوا اكتر من فاريبل. فاهماني؟ يبقى I will differentiate the first function with respect to the second function with respect to x. جبته. طيب in order عشان اخليها كبير بقى خالص. This function how many variables?
2.
The output how many variables? How many functions?
2.
So it's a 2 by 2. So the Jacobian will be 2 by 2. I will take the first function, differentiate with respect to x, then with respect to y. The second function with respect to x, and then with respect to y. So it's from R2 into R2. This is going to be from R3 into R2. In this case, I will differentiate the first function with respect to x, the first function with respect to y. Then the second function with respect to x, the second function with respect to y. Okay? In this function, or in this problem, I will differentiate the first function with respect to x, y, and z. The second function to x, y, and z. That's the derivative. Boss. That's the first function with respect to x, y, and z. Second function with x, y, and z, similar to this one. This is the Jacobian, and I will need the Jacobians in once you need to find the first derivative for vector valued function. What's the vector valued functions? the functions with several variables, but with several outputs. This is what's called a vector value function. That's another example, exactly the same. There is nothing new. Okay? So that's the gradient vector. That's the definition of the gradient vector. Okay? And most of our lectures are available on YouTube. Okay? For this part, I've already uploaded all these vectors in the previous week. According to, I believe, Jana or Neda, they asked for this. Okay? And also the PDFs, you already have them. Please, I beg you, try to solve. Use your pen and paper. I know the time is really very close and hectic for the next exam, which is going to be on Wednesday, but please try to do the best that you can. Okay, for the main questions, you have plenty of advantages with the coming exam. Number one, it's 16 problems. The 16 problems are multiple choice. Each one of them was 5 choices. Okay, there is no penalty, so it's really very good compared to what we suffered in linear algebra and the pain that we suffered previously. Okay. Number two, try first to solve the problems. That's easier on you to write the steps. By the end, if you don't know any problem, just give it. I
guess.
Yes, I guess. Okay. Since there is no penalty. I myself, I would prefer if you solve using a pencil, but use B or 2B. The thickness or the type of the lead of your pencil, let it be B or 2B, okay? So, you use pencils with B or 2B or 4B, it's okay. As long as the number of B's increases, I'm happy. Because it's gonna be a very thick, a very dark lead. You are writing with a black pen, okay? Use your blue pen for writing your name and the ID, but the rest you can use a pencil, because if you need to scratch something or to do something, it's gonna be easy. For the exam, you will have two notebooks. One of them is the draft with the solution, and the other one the questions. So use the questions and the answer in the answer sheet that will be something. Also, I want you to remember your Lisbon ID. Please enter the exam with your Lisbon ID. I need you to write them in the attendance sheet. Probably, I'm not going to be with you within the exam. Probably also, Dr. Karina, I believe she will invigilate on you. Okay? You have everything. You don't have any questions at the time being. Okay? Just to go the exam step by step. If I finish my lectures, because I will have lectures at the same time, I will come to check on you. Okay? But other than that, as I told you, try to solve, rearrange your thoughts, and it's not that difficult. Okay? Thank you very much, and I wish you the best in all times. Thank you. Bye.
Thanks.